like shirts. We have like.
I got 6 of them. I got 6 of them because it gets 6 get 3 and 3.
Okay, so we're getting close to the end of this chapter. I think we have 2 more sections. Maybe 2 more sections. So we're multiplying a monomial by a polynomial by a monomial. What we're going to do is we're going to get the distributive property, and then we combine like terms. So in this case, it's just like what we do normally when we see something like this, and we had a number on the outside of the parentheses number, we just multiply through and multiply by everything on the inside of the parentheses, right? So we do exactly the same thing here, except in this case we have to be worried about exponents and making sure that we use all our rules there. Okay, so if I'm looking at just this negative 2x squared times this 3x squared, what are we going to have?
Negative 6x.
Good, because when we're multiplying, what do we do to those exponents?
Yeah.
Right, yes, we add something close to this 4. Okay, what's the negative 2x squared times the negative 7x? 14.
That's.
Ooh, not x squared, but
cube.
cubed. Yep, because we have to add that exponent because it's a 1, right?
That's negative.
And it's a plus because it's a positive. Good. Okay, then what's the negative 2x squared times a 10?
Negative 20.
Yep, negative 1x. And that's all it is. That's all we do.
Okay, so you can multiply terms that.
Right, but you just can't add. Okay. Yep. Alright, let's look at B. So if we're going to distribute through to distribute twice, what's our first term?
35x. And so the third y.
Good.
And then minus 7x
Okay, now in example 2, notice we're doing exactly the same thing, except we have 2 groupings. We've got 2 set of parentheses. In this case, we're going to have to distribute it twice. So we're going to have to distribute these 2, and then we're going to have to distribute over here. Okay, so let's distribute on the left first. What's our first term?
12d squared.
Good. Then what we got?
20.
Plus 20d. Okay, now I'm going to be very, 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 very careful on this second step because I'm not taking it just times d, I'm taking it times negative d. Or d. Yes, true. But we have to watch out for the negative. So what's a negative d times a positive d squared?
Negative d to the third.
Good. Okay. Negative d times a negative 7d gets us a
Plus 7d squared.
good. Okay, and a negative d times a positive 12 gets us a minus 12d. Okay, so we are almost done. Now we just need to look and see, are there any like terms that we can put together?
20
Okay.
and 12d squared and 7d squared.
Good. Okay, now remember that we usually want to put them so that we have the biggest exponent first, just because it makes things easier to check, right? So what are we going to write down first?
Minus d cubed.
Yep, minus d cubed. And then I would cross them off, as I did before, to make sure that we know that we've already used that one. And then we need to put with the squares, right? So what's 12 plus 7?
19d
Good, 19d squared. And remember, it stays a d squared, it's not a d to the fourth. I'm multiplying anymore, we're just adding. Adding, you don't do anything with additions. Alright, what's the last term?
20d.
18, because we take 20 minus 12 to get 8. Now, it looks really yucky with all those exponents and variables, but it's fine. Okay, let's try B. So distribute through, and distribute through. I wonder what we have for this first group.
4 and then minus 4 and 3. Minus 4.
That's 40. There's no e in that one. Now what do we do? Is it? Why can't we do anything more? Yeah, just gotta like terms. So what I would do is I would just rearrange so that we have the biggest exponent first, and since we start with the n squared, I'm going to put this other n in there, and then the n in, and then the n. And this one, like, order isn't so much important as it was in the last one, but it just makes grading and correcting. Okay, any examples so far? Thanks. Okay, or I should say questions. I can't talk. Any questions on things? No questions on things. Okay, let's look at example 3. So it says that Greg pays a fee of $20 a month for his cell phone service. Text messages are 5 cents each. He also has a data plan that charges 6 cents for each email message sent or received. Suppose on Greg's cell phone or phone bill for January, text messages and email messages are grouped together for a total of 300 messages. Use T to represent text messages. Find an expression for Greg's phone bill for January. That's a lot of information there. What do you guys think?
$20 a month.
$20 a month.
Plus 5.05x per T, and then plus 0.06 year after.
Okay, you're right. We don't know what email messages are how many, right? Okay, so we know total together text messages and email messages were 300, right? And they just want us to use T. They don't want us to use any other variable except for T. So we're going to have to do something with that E over there. What do you think? Okay, well, how can we take this piece of information? How can I use that and write off to the side?
You would want to do like 11 cents.
Yeah, we can do like 300 times 0.5 plus 0.6, or 0.05, 0.06.
Well, then that would make each message 11 cents each. Does that make sense? Not really. Okay, well, let's see. Well, we know if we wanted to, we could write off to the side that we know 300 is equal to text messages plus email, right? How would I write this? Email. How can email by itself? Minus 2. So I know 300 minus the text message gives us an email, right? Okay. How about text message? If I want to get text by themselves, 300 minus E. Does that help us out? Maybe.
0.05 parentheses 300 minus E plus 0.06
Oh, we're so close on the right track. But which is the variable that they only want us to use? They only want us to use texts. So do we really want to mess like this one? Probably not. We'll leave it there, right? But still, you're on the right track because we want to put in something other than E. What can we put instead of E? So you're right, we're going to plug it in. So we have 20 plus 0.05 times text plus 0.06 times parentheses 300 minus the text. So we we don't know how many texts or emails he got. But we know together they make 300, and they just want us to go in terms of text messages. Okay. Can we make this looking pretty good yet? Can we simplify it a bit? Okay, we'll give you distribute first. Running out of room here. So
is 6.06 times 300 is 18.
okay, thank you. And then minus 0.016, right? Can we do anything else?
The 2018.
Mhm.
And then the 20.5T and the earlier 26.
Good. Okay, so what's 20 plus 18?
38.
38. Alright, and then the 105 minus the 106 gets us what?
0.2. Wait.
Right, and then it asks us to evaluate the cost, so we had 37 texts. So we're just going to plug in for T, right? Probably maybe check our answers to see if that is a reasonable thing.
Does that go to the second line, 20 plus 0.05T plus 0.26?
Okay. You can put in your T there. True. What else could we do? I would maybe find how many email messages that would be used as, and then plug those back in up here and see if we get the same answer. Okay, so if we had 30 set of texts, how are we going to figure out how many emails we got?
300 minus 37.
So what's 300 minus 37?
263.
So that's the email, right? What was it?
263.
263. Okay, and text was 37. Alright, so put those in for T and E. We end up with 37 and 63. I think we probably do. Isn't that cool how that works? Plug it in up there and plug it in down here and you still get the same answer? That answer. Put it on the map. Alright, any comments, questions? Why we get anything later? Okay, let's look at this last one. This last one we're looking about equations. Many equations contain polynomials that must be extracted or multiplied before the equation can be solved. So this looks really yucky, doesn't it? But we can simplify it by distributing through and then combining like terms, and it will distill itself down to something much, much, much simpler. Okay, so let's do some distributing. So that's all of the distributing. Check my math up here, make sure I did everything right. Get some bars. Okay, now what? Okay, and I would look at just one side at a time. So I'm looking at just the left side. Then we're going to do exactly what it said. We're not going to do the opposite yet. So we're moving it from one side to the other. So this would give me 2y squared. Now we can put the regular y's together to get good. And then the 25 just stays. Okay, then I'm going to look at the other side. Because there's no light to right. Okay. Now. Yeah, which one are we looking at? Okay. Yeah, if we subtract this one, what happens to this guy? Yeah, it will cancel. That's nice, we don't have to worry about the square.
We can just go all the way. So we're going to
Yep. Yeah, all that we have to
So the ones that have the equal sign, we just swap all the way. But like the ones that we did up here, we just simplify.
Right, because there is no equal sign, so you can't figure out what any of the variables are here, because they're just asking us to simplify it or evaluate. Down here, they want us to actually solve. When it says solve with an equal sign, I just want to put on.
Okay.